Okay, in this lesson, we're going to talk about nonlinear regressions. And we're going to talk mainly three different types of regressions. The first is a linear, which is a line which looks like this. Okay, a line looks like this. Y equals mx is an example of a line. And there's your example, y equals minus 5x plus 5. Now, we've been practicing these, so other types of lines that might be included. Let's go another, maybe distance. Let's see. Distance equals um, 3 times t plus 7 or something, where d is the distance. Make sure you always label it, okay, in meters, and t is the time in maybe seconds. So make sure you always label your units for these things when you do them. So there's time in seconds, and you label what each variable means, if there is a variable. So we've done the linear ones already, and we can find a line of best fit. The next one's a quadratic relationship. So for the quadratic relationship, it has an exponent of 2 on top of the x, or on top of a variable. So an example, besides the one that's here, okay, quadratic's the second one. See, quadratic, and the picture of the quadratic, it looks like this. It opens around like this and comes around. And there's one example. And remember, the x squared goes first, the x goes second, the number third. So you could do this one, the d equals minus 5t squared plus 10t plus 20. Okay, the d might be distance in meters. So make sure when you label the stuff, you tell me what in meters. You tell me what the variables are and what they mean. And t is the time in seconds. And the third one there that we're going to look at is exponential. Okay, and there's an exponential curve coming up here. It goes up like that. And there's the format, y equals ab to the x. I got an example. Y equals 3, 2 to the x. Okay, so in last year you should have dealt with lots of exponents. And the curve looks like this. It starts here, comes up. So last year in grade 11, you should have dealt with them. So let's just fold this sheet. I'll show you. You would have done maybe doubling or tripling time. So you might have said the amount of bacteria. So B is equal to, maybe it started off with 100 and it tripled every t minute. And you would have wrote it like that. And you would have said, okay, that's the starting 100 bacteria. So B would have been bacteria. And T would have been like time. Okay, and it could have been in hours, years, months. You would have done that, or sometimes cost. You could have had a cost equation, and maybe you start off with 1,000, and then it went by 1.05, so increased by 5% to the t. Or you could have done one that decreased, the cost that decreased, maybe 1,000. 0.95 were decreased by 5%. And these are equations these are exponents here, and the ones you should have saw last year. Now, we're going to find the equation of best fit, okay, and we're going to find the something called the equation of best fit, and then we're going to find the r squared. The r squared is the coefficient of determination. All three of these have an r squared. Only the line has a correlation of coefficient. Okay, does not have. Okay, the other two with the exponents has r squared, so does the line, has the coefficient of determination, but only the line has the correlation coefficient. It is a measure of how well the curve fits the data. The closer it is to 1, the more accurate it is. The closer it is to 1, the more accurate it is. In the next video, I just wanted to go over one exponent and how to use the software to find exponents.